2.8 Objective 3. The student will understand how a function can fail to be differentiable. What are the ways in which a function can be differentiable? Well, we saw one of the ways in the last video. We saw that the function y equals absolute value of x is not differentiable at 0. And this figure, 5a, shows that its graph changes direction abruptly when x equals 0. Okay, so how can a function fail to be differentiable? What does differentiable mean? Differentiable means that differentiability at a number a is that f prime of a exists. What is f prime of a? The limit as h goes to 0 of f of a plus h minus f of a all over h. For one reason or another, that does not exist. And it doesn't exist at 0 for the absolute value function. Okay, it's not smooth there. It's not differentiable. In general, if the graph of a function f has a corner or kink or cusp in it, then the graph of f has no tangent at this point, and f is not differentiable there. In trying to compute f prime of a, in this particular case, we find that the left and right limits are different. Theorem 4, which is if differentiable then continuous, gives us another way for a function not to have a derivative. It says if it's not even continuous, then it's not differentiable. If you can't graph it without lifting your pencil from the paper, then it's certainly not smooth there. So at any discontinuity, for example, a jump discontinuity, f fails to be differentiable. A third possibility is that the curve has a vertical tangent line when x equals a. That is, f is continuous at a, and that the limit as x approaches a of the absolute value of f prime of x equals infinity. Okay, so if it has a vertical tangent, then, what's the derivative? Derivative is slope of the tangent, but the slope of the tangent is undefined, right? Slope is undefined for a vertical line. This means that the tangent lines become steeper and steeper as x approaches a. Okay, so we can see that in figure 6. As x is approaching a from either side, the tangent lines are getting steeper and steeper. Another way that can happen, we see in figure 7c. That's another way you can have a vertical tangent. Okay, so the three possibilities, three ways to be not differentiable. Vertical tangent, discontinuity, it's not going to be smooth if you can't draw without lifting your pencil from the paper. You might, look at actually this vertical tangent in this form of it and say, well, that looks smooth. Okay, I'll give you that. It does look smooth, but the function is differentiable at a. So just remember the three ways. Okay. Third way is a corner or a cusp, such as in the absolute value function or this one pictured here in a.